Welcome to the CompTIA A+ 220-1101 or Core 1 exam. This is Objective 1.4 Mobile Device Connectivity. Many of the things we do in our normal work day involve using our mobile phones, and these are our cell phones. And we call them cell phones because they are using a cellular network. We call it cellular because they are separating up the geography into sections of cells. And we put antennas at the edges of those cells so that we're able to maintain connectivity wherever we might happen to be. Some of the original cellular networks were called 2G networks, and they consisted of two global standards. One of these standards was GSM, or Global System for Mobile Communications, and the other is CDMA, or Code Division Multiple Access. Both of these standards were very good for voice communication, but they had very limited support for sending data over these wireless networks. They were originally circuit switch networks and really had to be upgraded to allow some type of data connectivity. GSM was a big part of that very early cellular network, GSM being the global system for mobile communications. GSM was about 90% of the worldwide market. It was a standard in the European Union, allowed you to have coverage wherever you happen to travel in the world. In the United States, common GSM networks were AT&T or T-Mobile networks. This GSM network allows you to have your phone configuration on a subscriber identity module or a SIM card, and you can move that SIM card from phone to phone, and your phone number would follow you depending on where that SIM card happens to be. The GSM standard used multiplexing to be able to have many people communicating at the same time over the same frequencies. Every user got a little slice of time and could send the information, while other people were also conversing on the same network. This allowed people to perform voice communication, data communication, and combine all of them across one geographic location. CDMA is a code division multiple access. And as the name implies, you have to have multiple people communicating over this network. But as they were sending information, they were sending it with a particular code. Each call used a different code to be able to communicate, which meant that the handset that you were using could filter out codes that were important to your conversation, and you could focus on the code specific between you and the one that you're talking to. In the United States, CDMA was commonly used by Verizon and Sprint. They controlled exactly what handsets you're able to use on these networks. And unfortunately, CDMA wasn't popular in other parts of the world with other providers. As more and more people needed additional capabilities on these mobile networks, we needed newer standards that provided additional features. One of these newer standards was the third generation or 3G technologies that were introduced in 1998. This allowed us to have much more capabilities for the data that we were sending from our mobile devices. And we had additional speed so we could send more and more data faster over these same networks. Usually we got about several megabits per second of speed over the best possible 3G connectivity. With these enhanced speeds, we were able to introduce new capabilities for our mobile handsets, such as GPS, mobile television, streaming video, streaming audio, and video on demand. It became very clear that the separation between GSM and CDMA were creating a number of challenges for users that wanted to move between different providers or use different networks. To be able to converge these together, we had to use a technology called 4G in the cellular world, and 4G LTE stands for long-term evolution. This long-term evolution converged standards so that companies that used to be GSM or CMDMA can now just use LTE to send data over a wireless network. Well, it's actually based on GSM technology and what we call EDGE, or the Enhanced Data Rates for GSM Evolution. You combine all those together to create this newer LTE standard, and it increased the throughput up to 150 megabits per second on the best possible mobile connection. In some areas, you may find an upgraded version of LTE called LTE Advanced or LTE-A, where it is effectively double the throughput on those LTE networks up to 300 megabits per second. In 2020, we introduced a newer generation of mobile connection called 5G or fifth generation cellular networking. These 5G networks introduce greatly enhanced speeds, and we will eventually have 5G networks that can perform around 10 gigabits per second. These 5G networks greatly enhance the speeds that we can use for data over these mobile networks. And in the best possible scenario, we should eventually get up to 10 gigabits per second throughput from one single mobile device. And these networks are rolling out, and you may find that you have speeds between 100 to 900 megabits per second, and is still much faster than the older LTE networks. If we are able to greatly increase the speeds of data going over these 5G networks, then we may be able to extend the functionality of our mobile devices. This could be especially useful for Internet of Things and those types of devices where you have many different devices on the network that need to have some type of connectivity. If bandwidth and speeds are suddenly not an issue, then you should be able to greatly increase your capability of these IoT or Internet of Things devices. This would allow us to have much larger file transfers. It might increase the capabilities of applications that we're using, or we may be able to upload much more data into the cloud for additional processing. Many of the updates for our mobile devices occur in the operating system or the device itself. One of these updates is a PRL update. This is a preferred roaming list that allows your phone to understand where all of the appropriate towers are for the network that it happens to be using. This can be updated over the air, so you may see that your phone is performing an OTA update. And if that's occurring, it may be because of a preferred roaming list needs to be changed on your device. On some mobile phones, you can combine or merge together the cellular network with an 802.11 network. This is when you turn your phone into a Wi-Fi hotspot. This is effectively your own personal data router that's using the cellular network to communicate to the internet. So you could turn your phone into a hotspot. And now any other device in your area that communicates over 802.11 can use the internet connectivity that's on your cellular network. Your phone may support Wi-Fi hotspot capabilities, but your provider may limit what your phone is able to do. There may be an additional charge to enable that capability, and there may be data costs associated with the information you're sending when you're in this Wi-Fi hotspot mode. You'll want to check with your cellular provider to see what options may be available for your mobile phone. Okay, we are at the end here for Objective 1.4, Cellular Network Connectivity. We have a great question here. What cellular standard merged CDMA and GSM? So yeah, these two type of networks were competing quite a bit and used different towers and technologies. Which technology merged them together? So we have A, 2G, B, 3G, C, 4G, or D, 5G. And the answer is 4G. Yes, actually when 4G LTE came out, they merged these two technologies together. All right, thanks so much for watching.